Hi, welcome to today's session on area of 2D shapes. So when we're looking for the area of 2D shape, what we're actually looking for is, beforehand we've done the perimeter, we're looking for the region, the part that's actually inside the perimeter, inside the outline. So here we've got this grassy area, and the blue line represents the outline of the shape, and we're looking for everything that's inside of that line. This area here, which is the area. This is a rectangle, so to work out the area of a rectangle, we simply multiply one side by another side. So the length times the width. One thing that we need to always remember though when we are talking about area is that our answer will have the little power of 2. Doesn't matter if we're talking millimeters, centimeters, meters, kilometers, feet. Does not matter what we're talking about. If we're talking about area, we've got to have the little power of 2, an index of 2, the order of 2, the exponent of 2. So we're going to have a little look at a couple of the area formulas for some shapes which you're probably very aware of. So the first one is going to be a square, and I've only labelled the length on this. That's because all the sides of a square are equal. So for this, I'm going to use area equals L squared, or length squared, because L times L is L squared. Putting numbers to that, we've got a length of 5 centimeters. So my area equals 5 squared, which gives me an area of 25 centimeters squared, that power of 2. Rectangle we've already spoke about, which is length times width. So A equals LW. And putting some numbers in, I've got a length of 5 centimeters, a width of 3 centimeters. So 5 times 3 gives me an area of 15 centimeters squared. Again, the power of 2. And for a triangle, we are talking about the base. Some people do refer to it as the length and the height of the triangle, how tall it is. And what we do multiply these two together, same way as what we do with a rectangle, but we also halve our answer. So putting that in context, we've got a base of 5 centimeters, a height of 4 centimeters. So my area is going to be 4 times 5 divided by 2. 4 times 5 is 20. Halving that gives me an area of 10 centimeters squared. Here we've got a parallelogram, and to work out the area of this, it's simply the base times the height, because this is a rectangle which has just been pushed over slightly. If you imagine that a rectangle, we would normally be taking the length times the width. When we push it over, we're just taking the height times the width. So the area of this is base times height. So it's got a height of 4, a width of 5, or base of 5. So that means that the area of this is going to be 20 centimeters squared. A trapezium, as many of you may know, a trapezium has got two parallel lines where one line is not the same size as the other, as its opposing side. So I've labelled the top side as B, the bottom side as A, and we've got the height. What we're actually going to do is we're going to take our two lengths and we're going to add these two together, and then we're going to halve it, and then we're going to multiply by the height. So putting this into context, we've got a top length of 3, a bottom length of 5, and we've got 4 centimeters as the height. So we end up with 5 plus 3, which gives us 8. Half of that is going to give me 4. 4 times 4, that gives me 16 centimeters squared for the trapezium. And for a circle, some of you may already know this one, but we are going to use the radius, so the line from the center of the circle touching the circumference, the length of this, and we're going to multiply that by pi after squaring it. So some of you may remember that area equals pi r squared. Some of you may remember it as area equals pi times the radius. Some people like using this technique because only the radius is being squared here. By doing it this way, you're making sure that you are not squaring pi at the same time. Whichever way works for you. Putting numbers into there, so I've got a radius of 4 centimetres. So pi times 4 squared. So that gives me an area for this circle of 50.27 centimetres squared to 2 decimal points. We could also be asked to find area of compound shapes. A compound shape is a shape which is made up of multiple polygons, multiple shapes that we can measure, or even with shapes with some shapes taken away from it. I'm going to show you a couple of examples of these. So here we've got an L shape with lots of sides, 15 meters this side, 7 meters that side, 10 meters that side, 8 meters that side, 5 meters that side, and 15 meters that side. Now, few people would approach this in two different ways. I'm going to talk about one way, and then I'll talk about the second. So, a lot of my learners, they always take a look at the L shape and they'll think of it as two rectangles. So they will either split it here, creating a rectangle here and a rectangle here, or they'll put a line going across and cut it into a rectangle here and a long rectangle at the bottom. I've labelled these A and B just because I'm going to find the area of A and then I'm going to find the area of B. So the area of A is 10 times 7 because this length because remember I've gone and cut this shape across here. So my length here is 10 meters by the width, which is 7 meters. So 10 times 7 gives me 70 meters squared. Meters because our measurements are in meters. The area of B is 15 times 5. 15 meters is this entire length, and 5 meters is the height of this length. In which case, 5 times 15, that's 75 meters squared. Now to find the total area of this shape, I'm going to simply just add them together. So 70 plus 75, that gives me 145 meters squared. Now some people approach this in a different way. They'll actually complete the shape. So they imagine a line going across here and then down here. They'll work out 15 times 15 to work out the total area, and then they'll work out the area of the 10 times the 8 and take that away from the 15 times 15. Again, really good method, nice method to use. So like I say, we could take away shapes, away from shapes, and these are still compound shapes. So we've got a rectangle cut out of a bigger rectangle. So again, I've labelled them A, B. I'm going to find the area of my rectangle A. So 8 times 7 or 7 times 8, that's 56 centimetres squared because my measurements are in centimetres. Area B is 3 times 4, which is 12 centimetres squared. And then I'm going to subtract my smaller area away from the large area because that's going to give me what's left. So 56 take away 12, that gives me 44 centimetres squared, and that's the area of the green part of this shape. Now, a bit more of a complex question that we could end up having to solve is to calculate the area of this orange square. Now, some people might be looking at this and thinking, "Oh, this looks really complicated." But let's break it down. We've got a big square here, which is 10 centimeters by 10 centimeters, and we've got a square on the inside. But relatively, what we've got around the outside of this, creating the square, are 4 triangles. And we can work out the area of triangles because the area of triangle is base times height divided by 2, or halving. Now you might be looking at this and thinking, well, I've got a length or base maybe, or height of 7 centimeters. How do I get this length here? Bear in mind this is a square, in which case this is 10 centimeters. This entire length here is also 10 centimeters. In which case our length up here is going to be 3 centimeters because we'll take the 7 away from 10, and that will leave us with 3 centimetres. And that 3 centimetre length will be the same down here, the same here, and the same here. So we've got 4 purple triangles. So I'm going to do 7 times 3, and then halving that, and that's going to give me the area of 1 triangle. But I'm going to multiply by 4 because I've got 4 triangles. Putting all that into one sum, that gives me a total area of the purple triangles of 42 centimetres squared. Now, if I work out the area of the purple square, so 10 times 10, that will give me 100 centimetres squared. Now, if I simply take away the triangles away from the overall square, so 100 take away 42, that leaves me with 58 centimetres squared, and that is the area of the orange square on the inside. So we've just gone and turned a complicated question into a relatively easy question using knowledge that we already know. We can also use trigonometry to find the area of a triangle. So we are going to be using these facts here. So here we've got a triangle. The angles are labelled by capital letters, so angle A, angle B, angle C. And opposite each one of these angles, we've got the same letter but in lowercase. So we've got side A, opposite, angle, capital A. Side C, opposite, angle, capital C. And the height is shown by B times sine C. And this is capital C, so this is going to be angle C just over here. So to find out the area of triangle ABC, what we're going to do is we're going to use this formula here. Half AB sine C. And remember, that's capital C. So let's put that into context. My angle here is 30 degrees. I've got 5 centimetres for my B. I've got 6 centimetres for my small a. And this is all the information that I need to now complete this formula, because the inside height is going to be 5 sine 30 from the angle. So substituting these in, the area of this triangle is going to be half times A, which is 6, times B, which is 5, times sine 30. So multiplying all this out, putting this into the calculator equals 15. So the area of the triangle is a half of 15. So the area of the triangle is 7.5 centimetres. And that's using trigonometry to find the area of a triangle. It might be slightly different from base times height. That's because we are using trigonometry. If you like what you see, please subscribe. Thank you very much for watching.